the microphone a little bit just because I know when I listen to it, it sounds like I kind of go in and out for the people joining us online. But this week, we're going to talk about inferential statistics, some big data, look at some big databases here from North Carolina Vital Statistics database, as well as the voter statistics. So we got a lot of different things going on. And this big data isn't really going to be all that quote unquote big. We're looking at a couple 100,000 records, and once you get to about 1 million records, Excel honks out on you. So to me, I like doing this with ArcGIS Pro. I like doing this with R. And so we tried to introduce some of these other technologies to kind of interface with these as well. And so we're going to do this within the confines of ArcGIS Pro. But one thing that everyone has is the project. How did the research symposium go? Was it good? Good. I got some pictures. How'd the posters go? Good. Okay, I like some maps. I like maps. It was good. In the announcement today, I'm going to send a link so everyone can post, put their picture, put your poster into the link so I can give you like your check mark for the final exam. And then whoever didn't submit anything, they're just taking the final exam on, in 4 weeks from today. And so after this, we've got 3 more classes. 2 of them will revolve around Python. One of them is going to revolve around deep learning and using some deep learning tools to detect automobiles from drone imagery that we collected out in the parking lot. So eventually what we want to do is create our own models, but we're going to use existing models from Esri, and they've got a few of them for like swimming pools, solar panels, cars, so that we got imagery and so this is a car, this is a car, this is a car, this isn't a car, so those are going to be, pretty neat. So I'm kind of learning these as we go because these weren't around when I started learning GIS 25 years ago. But one thing that's required of everyone is the project. Okay, so a major focus of this class, and basically half the grade is the exercises. The other half, the other 100 points is going to be the project. And then if you turned in, the poster, you got 100 on the 50 out of 50 on the final exam. But I want to focus on skills development because I think a big part is really marketing yourself. If you don't market yourself, who else is going to market you? I don't know who is. I'm not going to go market Alondra better than Alondra can market Alondra. I'll put in a good word for her or whatever, but you market yourself as well. And I'm sure professors here that are really good at marketing themselves, and we kind of joke and laugh about them, but we joke and laugh about them because they're really good at marketing themselves. They're very good at it, and they're really good at getting grants and being on things and all these other things that kind of come with the ability to market yourself and the good things that you do. And so what we're going to do here is we're going to create a Esri story map. Okay, story map, you log in using the same exact credentials that we have, but all it is just a web page that we have. And in this story map, what you're going to do is you're going to teach us a lesson on how to do something. Record a video, insert a map, solve a problem, whatever you want to do. And I've got a rubric for what we're going to do. So these are a couple students from last year. Yep, Barbara, professional headshot, look at that. But she wanted to teach us how to do data wrangling. And basically that's what we're going to do today. It's kind of a combination of wrangling, cleaning. Next week we're going to talk about data cleaning, where we look at negative speed limits and how do we programmatically kind of assess speed, programmatically kind of look at those. And in addition, today we're just going to look at kind of, a couple 100,000 records, a few 100,000 records, which is kind of kid stuff when we look at it. But you're going to create basically like an online resume where you teach us how to do something, because you can give this to employers and say, hey, look at this. This is some work that I have done. And she did some data wrangling. She created like 500. She created a 500 to 700 word mission statement. What does she like to do for education? This is a poster that she did, some maps that she made, and then she created a video, it was a 10 to 12-minute video on how to go through and create these maps. So you can see the end product of these maps here, where we were looking at germ food deserts. We look at diabetes prevalence. Some of the things we're going to be looking at today a little bit with the vital statistics database at the block group level. These are some food deserts that were extracted from the USDA Food Desert Atlas at the block group and tract level, and kind of superimposed them on top, which was part of a poster where we looked at the relationship between health disparities, food accessibility, food deserts, and prevalence of type 2 diabetes. And we're going to look at these, and we're going to just look at one data source where we look at health outcomes, it's particularly death, but there's lots of other kind of health databases out there that you can utilize, and use the Google machine to kind of figure out where those are. But this kind of talks about the process by which she went from these kind of green maps sitting in ArcGIS Pro to the finished products. So we turn these large large death, databases into diabetes map at the zip code scale for Durham County, where we can superimpose these and put some credits down there. I like the demographic data, the census tract, how to adding data to map, my YouTube channel. I always love getting credit, so you all know that. So this was one of them that we created. So when you go and sign, you go and do something, you go apply, people can see you. At the end of the day, if you get a job interview, that means you can do the job with people. That means like, all right, they can point and click and have all the credentials, but when you show up and look them in the eye and look at your face right there, and hey, this is someone that we want to work with. Okay, and that's the biggest, stumbling block. Why some people are able to get jobs, some people aren't, because job force is pass-fail course. It's not like we really loved your interview, but we still picked someone else. It's you didn't get the job where you got it. And I think that's what a lot of people kind of entering the workforce are, struggling with, struggle with. I got a daughter finishing college, and I don't know what I'm going to do. And some of it's her work trends, where people are like, I don't want to move to Iowa. Just go move to Iowa, go live in Iowa where they offer you a job or whatever. And so these are good ways to kind of let people know who you are. This is another one, Michael. He was a master's student here, undergraduate student here. He's in the PhD program over at North Carolina A&T. He's kind of like a second career student. He had a whole career in healthcare and went back to school, and so he used story maps. He created a nice little mission statement about me. This is online resume. He went to a local community college here. These are his skills. These are some maps that he's created. This is some AI/ML stuff, because we were looking to see if we can detect. Railroads from drone imagery. So these are some of the things he's created, and I'm pretty sure he created a nice little video right here on understanding artificial intelligence and machine learning and applied to GIS. And that's what we're going to do the last week, where we're going to, all right, just get a picture or image of the parking lot, find all the cars, and see how well it might not pick all the cars. So we might have a omission where it didn't pick out a particular car, or a commission where it mistaken a garbage can or something like that for a car. And so we can start to assess and evaluate some of those differences. And those are some of the things that I'm good at as well. So yes, one's in the workforce, making portfolios and maps is really good, preparation for the workforce. Because at the end of the day, that's what we want to do. Get you prepared for the workforce. That's the most important thing, get you out there. But this is the rubric right here. This is going to be due in 4 weeks from tomorrow. So it'll be due the 29th. It'll be due the 29th at noon, because I like to have everything done first week. No, I don't want to go into the second week, because I'm teaching field mapping class, and we're going to get into that talk about field mapping in a little bit, a couple minutes here. So we've got this. This is worth 100 points. Think about what you want to do. Think about what you want to share, because most of the time, if you want to find something out, what do? You go and you Google it, and I bet you at some point in time, someone has already done it. And so what are you going to contribute to the GIS world, the chemistry world, the biology world. What are you going to contribute? Say, hey, I know how to, I figured out something really cool and I want to share it with everyone. I think this is your opportunity to do that. Now, how do we turn big databases into diabetes stuff? And you could solve a topical problem like, hey, I'll show you what I did so I can map gun deaths. Or, hey, I'm going to show you how to run R or run Python so I can do this data cleaning algorithm or something like that. And so it can be a little bit more on the technical side, but you can see at the bottom here, I have something here for project difficulty. And so I am very stingy about that, meaning like, please make it hard, make it, I want to learn something, I want to learn something. So if you do a tutorial that says, this is how we print hello world and small basic, this is going, you might get everything else really good, but this is going to be a 0 and the minimum score, the maximum score you'll get is a 90. We've had that, we've had that before. And since this is kind of geospatial data science, I'd like it to be kind of a little bit more to working with geospatial data or geopotential data, maybe tabular data that it's stored in tabular format, but that has the potential, to be mapped. So we've talked about these here as well. The other thing, I'm talking about field mapping as well. I'm starting to kind of get ready for that. Field mapping is a little weird this year because field mapping is being offered May 5th to May 16th. May 5th to May 16th. I'll probably send an announcement out about it soon, and probably by the third week of April, I want everyone registered who wants me to pay their fees. If you don't want me to pay your fees, you can sign up like May 4th. I don't care. I'm usually paying for it anyway. But Dr. McGinn and I, we had enough money to pay for fees, not tuition, or pay for half of it. Put down we'll probably just pay. Hey, we're going to pay $700 for the class. You can apply for tuition fees. I don't know, Miss Powell probably pays for some of it. I don't know if she pays for the summer. I cover people's grant stuff. So, during the summer, but those of you, we don't offer, the department doesn't offer research assistantships during the summer. So you typically, need to take care of it, but that's one less semester you need to be here. And so we've got this field mapping class. It is Monday to Friday at 9 in the morning, but we're not going to meet the day of graduation because there's graduation going on, and then I got to go to see my kids' graduation the next day. But we're going to do a lot of different things here. But one of the things I was doing was that I turned my little phone into a GPS unit. And just now, I was walking kind of in a square here where, this is the building. This is Mary Towns. This is the Bright building, and I was kind of walking in this direction. Now, I didn't walk in this direction, so you can see how off I made like a big square around, and this obviously isn't a square. And so what we're going to do is we're going to have a field day, or we're going to have a class where we're going to go to Okanochee. How do you pronounce that? Okanochee Mountain. That, whatever. We're talking about this. Yeah, but they have a trail right there, and it has mountains. So what we're going to do is we're going to spend the day, we're going to spend half the day going over there, mapping it using our GPS unit. And I map it using my iPhone, and then you'll map it using your iPhone. I'm going to map it using my old GPS unit that I'm going to download. Someone else is going to map it using my high precision GPS unit, which is 1 to 2 meters. Someone else will map it using a Samsung, and then we'll superimpose these on top of each other and see which one is the quote unquote best. And so we're going to do that in the morning. It's like 1.2 miles, but there's a lot of preparation. You just don't wake up and start mapping and make stuff. Hey, I got to go to ArcGIS Online, or I can do this in ArcGIS Pro, and I've got to make a point feature class, a brand new point feature class, because eventually what I'm going to do is with these trails, I'm going to go and connect the points. That's easy to do in editor mode. I can make a separate point feature class. I can make a line feature class, because those things are two different feature classes. Remember, we had points, lines, and polygons. And so the lines are made of vertices, but those vertices are just connectors with they're just, connectors where that I want to keep these points, which have elevations and HDOP and PDOP, and we'll learn about what those are. And so I kind of look forward to going out and doing that, and us trying to get a paper as to like, is this really, if I use this, is it quote unquote good enough? How does the elevation? And we have some people who are really good with, 3D and time series and all this other stuff. So, hey, let's create an elevation profile of these. And how do these elevation profiles, because this thing's really, really bad when it comes to elevation. It's pretty good when I run, but a lot of times when I go running in a loop, I start at different elevations than I, end at. But it's pretty good at keeping my time and all that other good stuff. And so we're going to go to this mountain in the morning, and that's going to be the Monday after the graduation. And in the afternoon, I'm trying to get permission so we can take our drone and GPR down to the cemetery that we're working with and go and fly portions of, fly the whole cemetery and then take our GPR and do some field mapping. So the big thing we're going to do in that field mapping class is, make sure people can load up stuff, because creating a little point feature class, it just isn't like magic, because I had to figure out how to create streaming points. And I use something called quick capture because I can't do it in survey 123. It doesn't allow me to do streaming points in survey 123. I'm just looking at Chima and Daniel, making sure they're nodding like, yeah, Maloney's right. I'm right?
Yeah.
Okay, just making sure. Okay, but only in quick capture, which basically is a little application so you can quickly capture things. And then we have survey 123, which is a little bit more robust, where it collects, spatial location, but I can go and ask, oh, who did you vote for? What is your biggest pressing concern? How tall are you, or whatever. So I can collect both qualitative and quantitative data, as well as, take your picture and then go to the next thing, and the next thing, and the next thing, and so forth and so on. So they have different uses. And then we have field maps, which is kind of full blown, ArcGIS Online, editor capabilities, but I don't really need those out in the field. I really don't. So we're going to talk about some of the tools which best work. So it's going to be a nice sample of some of the things that we can do. But that class is going to meet for 9 days, Monday through Thursday, and then Monday, Tuesday, Wednesday, we'll probably have off, and then we'll have a presentation where you just present on some facet of one of the things that we did. Pretty straightforward. We try not to give homework. We give 5 assignments, 1 each night related to the Esri training tutorials. And then the big thing is just being active and participating, because, hey, we were going to need someone who, hey, we're going to walk on this trail, so you make sure we're walking in the right direction. Hey, you're going to be the Samsung people. Hey, you're going to be the iPhone people. Hey, you're going to be making sure my GPS unit is actually connected to my phone, because I could be walking around with my phone and I'm doing iPhone, but I really want it connected to the Bluetooth on the GPS unit that I'm carrying around. And that's what I started with today, because I was like, it's looking for my GPS unit, the Geo looking for the GPS unit, and it's not. And then we got people, hey, we got to make sure everything's plugged in and charged up, because I do not like to go back and have to go through things again, because that wastes our time, collective time and energy and all that. So really kind of getting the ideas of project management. What are the things, sitting here and making sure we create points, and hey, let's go out here and do it and make sure it works here, so that when we go out in the field, it's pretty seamless. And those are things that I still try to learn to this day, making sure I have the right stuff out there, because there's not going to be plugs out in a cemetery in rural Chapel Hill. So I better have my drones charged up and ready to go. I better have my GPR charged up. You better have your phones, charged up. And those are the things that people typically don't teach you in class, with the pointing and the flicking, that are going to be important. And, imagine telling a client, hey, I got to come tomorrow. I didn't plug in my GPR unit. It's got to charge up. What do you think they're going to say? No thanks, we're done, all these other things. So those are kind of parts of the tests. Kind of like when people email me, it's like, I don't know my password to Esri. I'm like, I don't know it either. I don't know it either. And so this is part of the field mapping class. It'll be quick. Hopefully it'll be fun and all that other good stuff. But today we're going to talk about hypothesis testing. You notice I've got a lot for exercise 7 right here. I got a whole bunch of tables, cities. So hopefully everyone has their GIS hats on, because we're going to be doing some GIS thing. And if you forget how to do some of it, then just go back to the recording later. Go back to the recording later, because we got a lot of different things we're doing here. We're doing some table merges. We might do a little attribute mapping. So I've kind of written to a lot of things and working with really robust databases, because these data will be created on an everyday basis. But we're going to talk about hypothesis testing, because a lot of times we make these blanket statements. We make these blanket statements like gun death rates are higher in urban areas than rural areas. Drunk driving is higher in urban areas than rural areas. COVID impacts this community more than this community. These are really, really easy to test. And we talked about this in geostats a good bit with the hypothesis testing, and I've kind of added to this a little bit because, we open up our phones or open up our computers, and we just see these statements out there that, can be easily proven. So like, is there a difference between cancer death rates within 1 mile of point source versus outside of 1 mile? And some of these can just be done using descriptive statistics. What's an example of a descriptive statistic? Me. Hey, 423 people died within 1 mile of this point source pollution. 723 died outside. Is that a good comparison? Well, the area within, we know how big, area within is 3.14 square miles, pi r squared. How big is the area outside? Oh, well, and so we talk about that idea of normalization. So we can look at these as rates, or we can say, hey, in the next, ring around that's what 1 to 1.4 miles away, because we need to create something that's 3.14 square miles. What's the significance of this 3.14? Why do I keep saying 3.14? Pi, exactly. It's just pi, pi r squared. And we have a radius, we got a radius of 1 squared times pi is 3.14. And so that's how we can create some normalization if we're not going to run these more robust ANOVAs or t-tests. So is there a difference between school achievement in rural schools versus suburban versus urban schools? Okay, we can check on those. How are socioeconomic indicators for high food accessibility versus low food accessibility? Are COVID rates higher in rural regions versus urban region? How do cancer rates compare to places near Superfund sites versus places further away? What's a Superfund site?
It's like a site that's been polluted, but the EPA's, there's funds for this EPA to kind of go in and clean it up.
Yes, clean it up or keep people away from it. Yeah, so Superfund site. I think I've got a poster up there, furthest one, closest one to the door there, on kind of the relationship or mapping of the Superfund sites, if I remember right. And so other examples, these get a little bit more tricky, like do DV collisions exhibit a Poisson distribution? What's a Poisson distribution? TAs aren't allowed to answer, okay? Poisson distribution, making eye contact. So exactly, displays randomness, exactly. Displays a type of random distribution. Are minority heart disease deaths significantly different than majority heart disease deaths at the zip code level? And so we can look for, hey, we can find heart disease deaths, we can denote it as minority, majority, or whatever, and see which ones have higher rates and look at a distribution of them, distribution bell curve of these, because we're going to look at how data are typically distributed. And if you remember from geostats class, we focused on this kind of bell curve distribution, normal distribution. Are by-mail voting patterns higher in COVID-19 hotspots versus COVID-19 cold spots? By-mail means people who literally mail in their ballot. Is there a relationship between areas with high COVID where, hey, COVID-19 hotspots, they're mailing them in at higher rates versus COVID-19 cold spots where the COVID rates are really low? And so we could go and make pretty maps like this, because a lot of my effort and a lot of the effort we'll talk about today is turning voting patterns, voting data, and we're going to look at a couple of them into maps like this. This was probably 2 days just to make a map like this from all the 7 million voting records in the state of North Carolina that Excel doesn't like. It takes a really long time to ingest, even into ArcGIS Pro. And I think I ran this through R, filtered it through R a little bit. And so we can look at a map. This is a spatial distribution of people who mailed in their ballot by mail in the 2020 general election. And you think the decision to mail in your ballot, just stick it in the mail would be a random phenomenon, right? I think it would be. Me versus you versus my neighbor, that has nothing to do with each other, but you can see higher near higher, lower near lower. Like, I just think that's amazing. This typically, or what I would think of, apparently, supposedly, a random phenomena that displays patterns on a map that can be grouped into hot spots and cold spots. The other thing we have here, this is COVID-19 incidence rates right at the time of the 2020 general election, where COVID was much more of a bigger deal. And then we ran these things here called hot spots and cold spots. Now, we're not going to revisit hot spots and cold spots. We're going to revisit the testing utilizing these hot spots and cold spots. So that's why we're doing geospatial here, where at the time of the general election, these are hot spots. Now, who remembers, how can you define a hot spot? High surrounded by high. Who says, what's high mean? Higher than what? The mean, exactly, the mean. And so we got some really kind of fickle stuff there with means. So if we have these really weird outliers, we might have to get rid of these, especially if we're dealing with small number problems, so that we get an adequate number of hot spots and cold spots and populated places. Because basically what I did for our paper, and we're going to look at the test later, is that these areas in red, I'm going to assume they have higher by mail voting patterns because they have higher COVID rates. Now, what do you think is going to happen when we look at that? It's actually the exact opposite. Now, remember, we're not in the why business. We're in the where business. Okay, we can let the sociologist, the biologist, or the chemist, or whoever else figure out the why behind it. And then these blue areas are the lowest COVID rates surrounded by other low COVID rates. So even though we had a really low COVID rate right here, it's not in a hot spot or a cold spot because it wasn't surrounded by others. And then what we have in the yellow is 3 different scenarios. One of them is just they're somewhere near the mean. There are highs surrounded by lows. There's lows surrounded by highs, or lows near highs, but they don't display it as high surrounded by low pattern. And then, like we talked about last semester, there's that whole caveat. What is a neighbor? What's a neighbor? Is a neighbor a zip code that touches you? Is it within a certain distance of it? Can we use some sort of distance decay or IDW, inverse distance weighting, to apply to it? So some sort of weighted average? What is a neighbor? And so we get into these deep philosophical questions that can change the entire tenor of what hot spots and cold spots look like. So what we did for our paper is that, hey, we just grabbed all of the reds and we looked at the distribution of by mail voting. We looked at all of the blues, looked at the distribution of by mail voting, which is going to just display a nice little bell distribution of, and if those means are somewhat near each other, we can say, no, they're not different. If they're far enough away from each other, using variance, mean, and sample size, then we can say, yes, they are statistically different and reinforce some of our hypotheses. Now, some of the issues to consider that I've already talked about is that we need rates. So COVID-19 rates, by mail voting rates, median household, by area. Hey, let's look at the number of people per square mile, number of cancer deaths per 1,000 people. All those other things that we were talking about with the point source pollution. Now, there might be other reasons why cancer rates are higher in areas near point source pollution, which has nothing to do with the point source pollution, but we're not going to figure those out. And then also make sure we maintain consistency, where if I'm looking at some of the things that Barbara did was she just looked at Durham County, which is largely a urban county for the most part, but if we're comparing like urban food access versus rural food access, just in terms of mileage or driving time, you're going to have very different results, because in urban or rural areas, we're going to expect to drive further and further away, farther away. That's the whole definition of rural. That's where places like Dollar General are really starting to find their market. You know, you go to a Dollar General kind of in a rural area, they're gonna have milk and eggs and bananas and all those other things there, and probably cheaper than other places as well. And so this is something that I did, and I've shown this before, but this is called PRTI. It's basically a unitless metric that shows relative access to food. So it's unitless. So it's not in minutes or miles or degrees or anything like that. It's basically a ratio. And so these red areas have the worst access to food. These green areas have the best access. And this access is just represented as a ratio of the distance to the nearest unhealthy food to the nearest healthy food. So these areas in red, these people have to drive 2, 3, 4 times further to healthy food compared to the nearest unhealthy food option. And there's a lot of rabbit holes you can go down as to what makes it unhealthy. Okay, we just said fast food restaurants, convenience stores, even though we know, fast food like, Subway and convenience stores have healthy options, but albeit they're going to probably be much more expensive than, supermarkets, which we deemed as healthy, where that at supermarkets, you can go get stuff that's bad for you, but I'm not gonna kind of mess with those. But when we look at the distribution here, we see a nice bell curve that's skewed a little to the right? So if we were to look at all, whatever we have here, 292, census block groups, you can see the distribution of these. And essentially, when we run the two-tailed t-test, all we do is compare superimposed two bell curves or two normal distributions on top of each other and see if they line up. And if they're further enough away from each other, we can say they're statistically different, and we can't prove the null hypothesis, or however we can word that. And so we can look at, hey, I broke these up into quantiles here, and so these colors right here, that we have these. And so, but one of the things with our two-tailed t-test is that, hey, I want to look at the best access versus the worst access. I want to look at the dark reds versus the greens and see if there's a difference between them. Just like we did with the reds and the blues. Hey, is there a difference in income between the people who have poor access versus the people who have the best access? Is there a difference in race? Is there a difference in income? Is there a difference in access to transportation? Who knows? Because I'm doing these wacky ratios right here, to be honest with you, right? Where that most people just say, oh, this is how far it is in drive time or drive distance or whatever. And so this is just another way to measure food availability or food accessibility as well. And so with our best access, I could say, hey, my best access could mean the average of those incomes is $37,000. With the worst access, the average of those 31 is $32,000. Are those statistically different? Is that big enough of a difference between those? If I were to kind of superimpose these bell curves on top of each other, are these big enough of a difference? And we'll get back to that answer in a little bit. Other things that I kind of haven't talked about a little bit is that we look at minority zip codes, majority zip codes with by-mail voting. Let's look at the minority zip codes. Okay, these are your highest minority, non-white, have a by-mail voting rate of 8.0. Your majority, your partly white zip codes, have a by-mail voting rate of 10.5 for these 163 versus 153. I probably got rid of like 10 of these right here because we had some no data values right there. But what are the chances that I had 163 just random samples and they had a difference of 2.5? What are the chances? Not very good, I think. We kind of use the example with height. I can make an assumption or I can make a hypothesis that says, everyone at North Carolina A&T is taller than students at NCCU. And I can go find someone really tall here or go find someone really short. And all right, you proved my hypothesis. Now, I don't want to go get every single person on campus because that would take a long time. So we can go get a sample size got a distribution of heights that go from 4'11" to 6'9", and look at the distribution of those. And we can prove or disprove that hypothesis if we get a number from NCCU versus North Carolina A&T, which is based on the average of the 150 that we took versus the variance of the data. What's this word variance mean? Just how far it varies from the mean, as well as the sample size. The sample size is going to be important. Do I want 100? Yeah, probably 100, 150 would be good. I don't want 8,000 because, well, that would defeat the whole purpose of taking a sample of, getting everyone. But I don't want to get 2 because your margin of error is going to be really high, and by default, you probably will not have a difference. Even though if you had 2 6-foot people, 2 5-foot people, it's still going to say, hey, they're not statistically different because you only have 2 of them. Because your sample size is part of the equation. And I don't get too much into the formulas right here, in this class here. So a hypothesis, tentative assumption that can be made for the purposes of empirical scientific testing. What's this word empirical mean? Can be measured, exactly. Numbers, we attach numbers. I live, and I was at the AAG, Association of American Geography, last week. A whole lot of qualitative geography going on out there. I want no part of it. Okay, I want numbers attached, all these. How do you feel about this? Good. Good is a 4, bad is a 1, in between is a 2 and a 3. How do I attach those and I can map those? So we have these hypothesis statements. And those of you, because I love putting my papers up there, but this is a recent paper. I think this is the most recent paper we wrote where we use density metrics to measure food availability. I like making hypotheses with little bullet points that we can go prove and disprove, because a lot of times when you read these papers, you're going to have an abstract, you're going to have an intro, and then you're going to have a lot of fancy stuff that you may or may not understand, and then you get to the end with the conclusions. That's how I do things. And then I just kind of rip off people's lit reviews. Hey, what did people do in this lit review? Let me just rephrase what they did in their lit review, and then add a little of my original research, and I've got a lit review. That's all I do. And so we are going to use a working hypothesis that raster-based point density metrics to measure food availability is comparable to traditional vector-based counterparts. That's my working hypothesis. And then we kind of broke it down. Hey, we had a model. We use this model to find the least and available on the backdrop of socioeconomic demographic data. And then we compared, we kind of figured out a little tool so that we compare this density metric to distance metrics, density metrics, to measure food availability. And I think we did about 6 or 7 of these. Here's another one that we have. This was the COVID rates versus the by mail. This was only a 3,000 word essay. This is the max that we could submit for the professional geographer. And we said, using a working thesis that regions with higher COVID rates would have higher rates of mail-in ballots, we will use statistical comparisons, geostatistics to determine the impact of COVID-19 on by mail. That was our working hypothesis. We actually found out the opposite. I think I've got another one right here. This one was on rural food security. This paper would determine if rural food security is even a problem in North Carolina. Is it a problem? Because whenever we hear about food security, what do we hear about? We hear about urban food security for the most part, because a lot more people live in urban areas as opposed to rural areas. And actually what we found out was more people live in areas with higher rural food security than urban food security. More people, higher percentage in rural, but more people obviously in urban areas. If rural food security does exist, where does it exist? And then what ages, races, ethnicities may be most impacted by rural food insecurity. So we kind of picked out all the areas of rural food security, and we kind of delved into those. And to first of all, see if there was a problem. Like, hey, if 15% of the people in rural areas have food insecurity and 15% of the people in urban areas have food insecurity, then it's not really being differentiated. And then I can prove or disprove it. And then we kind of start to look at things like hey, we have property crimes in neighborhoods furthest from public housing versus with large public housing. Let me average up these. Let me average up these. Let's see if there's a difference between these. Now, we see a lot of these descriptive. Now, we're going to just look at a normal distribution of these versus a normal distribution of these. But at the very minimum, we could do what they do in sports. Hey, this team won 17 last year, 22 this year, 16 this year. Over the last 10 years, this team has won an average of 7.2 games. Those are really easy descriptive statistics that we can derive from our data fairly easily. And so we have some tests for statistical significance, meaning when I put up the bell curve or the distribution, and typically when we look at normalized data, it's going to display a normal distribution. What are the chances that those two bell curves, those two normal distributions line up with each other? Okay, and if they do line up with each other, they're equal to each other. That's it. That's it. So we can never find or ascertain that there's a 100% relationship between two variables. To me, the word, and depending upon who you talk to, significant means not likely to happen by chance. What are the chances that this low axis has a median household income of $32,000, while the high axis has an average of $38,000? We went through some statistical tests that'll give us a little p-value, but we can never say they're statistically certain. And so when we do this, all we're doing is taking a random sample, kind of like the example with the height. What if I said, made my assumption or made my hypothesis that all students at NCCU or students at NCCU are taller than North Carolina A&T? Are the first people I'm going to go interview are the basketball team? No, because they're going to increase, they're going to increase the height and scale it. Where would I go? Okay. And these days, even with polls and surveys, they're always going to be biased. There's always bias with those. Why? Because if you put a poll on the internet, well, it's biased against people who don't have access to the internet or choose not to or don't utilize it or whatever. And so to me, these days, it's really hard to find, biased lists or unbiased, surveys. But it doesn't necessarily guarantee a representative sample. So if I just sat in the student center right at the entrance for an hour and measured everyone's height who happened to walk in, well, what if the basketball team happened to walk right by me and I took their height? Well, there it is. I'm not going to say no, just because they're walking by. I don't want to skew it or anything, because there might be the cheerleading team or someone who, folks who might be, notoriously, shorter or whatever. So who knows? And so when we work with sample data, some of the things we have, and especially older Esri data, it told us things like confidence values, margins of error, like how good is the data? Because even now, when you go to the census website and download data, has anyone gone and downloaded data from the census at the zip code level, the tract level? It's fairly easy, it's fairly easy. It takes a long time. This is where you make your bucks in GIS. Downloading that stuff, making sense of it. At the end, it's usually going to have something that says like plus or minus margin of error. And sometimes it's like median household income is $50,000 plus or minus 500. Okay, that's pretty good. Other times it's going to be $50,000 plus or minus $15,000. So it could be $35,000. It could be $65,000. That's a pretty wide range that you can have it. Why? Because things called imputation. They're not sure how many people live within that area right there. There's not that many people that live in that block group or census tract to collect. So your margin of error with that calculation is going to be high. And so typically, sometimes with Esri data, you might get low reliability, medium reliability, or high reliability. And so a lot of times, census data comes with a lot of different attributes. A lot of times we look at what we call SF1 data, which is age, income, not even income, age, race, ethnicity, housing status, where it's answered of everyone. But these days, we're getting census data on between the censuses from something called American Community Survey. So you can go and download those data, but they're not all necessarily as reliable as the others, and some attributes as well. If you're looking at the percentage of people from Vietnam in 2020 for this particular block group, there might only be 1 or 2 people from that country, and it might not necessarily be, reliable. So pay attention to those plus or minus or those margins of errors as well. And so going back to our question here is, I want to see if median household income is the same for the highest quantile versus the lowest quantile. And we're going to use something called a two-tailed t-test. At my conference last week, I kind of used this. We have something called the null hypothesis. Well, we're going to assume in this low access area, they have the same income as the people in the high access area. That's what our null hypothesis. Just like my COVID, where I'm going to say those people in the red areas have the same buy mail rates as those in the blue areas. We're going to assume they're uniform across and then use our test to see if they're different. And so we assume that there's no difference between the groups. And then we have something called an alternative hypothesis that's going to say one is greater than the other. And basically when we run these, we just basically try to disprove this. And some of the things with statisticians, I'm not a statistician, but people get really fickle about how we word these things. You never, all you want to do is prove the null hypothesis, because if you disprove it, you're really not proving this, you're just disproving this. So you can have things called type 2 errors. But I'll talk about what I did for my paper last week at the presentation. So what is the chance that if the population means are the same, what is the chance that I have one set of data that has an average of $41,000 versus $32,000? Just kind of grabbing random block groups, what are the chances that I have a difference between those? Really, really, really small. Well, let's see. And basically, I can look at these distributions, and if these things get far enough apart with our little formula here, because this is our little formula. Who wants to do math here? We just let Excel do the math for us. That's all we do. We pop it into Excel, and then we let Excel do the math for us. And hopefully, we're going to have time today to do that, because we're going to stick around for a while here, because I want to make sure we do the GIS. We are able to merge tables. We're able to do a lot of other things here. But when we run this in Excel, and hopefully today we'll get to this part, where that best access is $41,000, the worst access is $32,000, and I get a p-value of 0.01. Basically, I like to look at these, and this thing says, hey, or for two-tail, there is a 4% chance that these two things are equal to each other. That means we can say they are statistically different with 95 or 96% confidence. Okay, these are different. Okay, these are far enough apart. And I always mess this up from time to time, so I always kind of put in a couple values that I know are equal to each other and see what the p-values are. Oh, p-values are 0.87. Okay. And then I make some that are far apart, and then I run these as well. So I'm always running these to make sure they make sense. So to me, and what this says, it's highly unlikely the means are equal to each other, and we accept the null hypothesis. We cannot accept the null hypothesis. It's unlikely. And so when we look at data, typically this is what data looks like. We look at NFL teams. What's the average number of wins in an NFL season? 8.5 because of 17 games. Most of the teams are going to be between like 6 and 11. You're not going to have a lot of 15s and 16s. You're not going to have a lot of 0s and 1s. So most of them are going to be right in this kind of middle area right here. And so these middle areas, and these values here, use the word standard deviation. We'll talk about these more in geostatistics. And so when I look at a z-score, it's way over here. We kind of line these up, because basically what we did right here was did this. We had one distribution, we had another distribution, and they're really, really, really far apart. And they were so far apart, they were so far away from the means of each other, we could say that they're statistically different from each other. And so we can create t-statistics and all these other things. Now, the way that we report these, people get really fickle about these. And so we can say we can reject the null hypothesis. I just like to say they're statistically different at the 90% confidence interval, 95% confidence interval, 99% confidence interval. So when I look at something like this, where I see best access, worst access, and I get a p-value of 0.6, I know they're not statistically different. And here we're looking at spending on fruits and vegetables right here. So in our best access, they spend $422. In our worst access, they spend $393. Now, I know 422 is more than 393, so I can say on average, they spend more on fruits and vegetables than your worst access, but I can use the descriptive statistic, but when I run it through my two-tailed t-test, I cannot say they're equal to each other. Things about p-values, the lower, the better. The better for proving statistical difference. In some cases, you want to say they're the same, like, hey, people say that gun deaths are higher in urban areas. I'm going to prove that they're equal in urban areas versus rural areas. And so whether you're proving or disproving the null hypothesis, it's okay. And like I said, and I want to reinforce to everyone in this class, if you have a thesis or hypothesis that does not get proven, it's okay. Okay. I think a lot of times people like to put like round pegs into square hole, and try to manipulate the data so that their hypothesis gets proved. Because I can say, oh, let me change the word rural to 15 miles versus 10 versus 11.6 or 22.3 so that I can have statistical difference or statistical similarity based on my thesis statement, and that's okay. And so when we start to get these statistical values here where your p-value is 0.1, your p-value is 0.5, your p-value is 0.01, I can say with 99% confidence, I can say they're statistically different. With 99.9% confidence, I can say they're statistically different. And typically someone got really mad when I said p is equal to 0, so I use this little symbol right here. Because remember in geostats, we would get these cluster patterns, and they would be like p equals 0.00000000, like 23, and that's like really small, but we're never going to say 0. We're never going to say it's cluster. We're going to say there's a very, very high likelihood it's cluster. Very high likelihood they're statistically different. So we can use numbers like this. So now when we go back to revisit my COVID rates, you can see on the left, these are my high COVID cohorts. On the right are my low COVID rates, okay? And the first thing I did up at the top was I just broke them into quintiles. What's a quintile? Quintile. What's quint mean? Fifth. So I just broke the first, fifth, second, fifth, third, fifth, fourth, fifth, nothing to do with geography. And I found that they were statistically the same. Now, when I ran these again, you can see here with the hot spots and the cold spots, and we're going to do the one at 10:30 at October 30th, 2020. You can see a few days before the 2020 general election, the hot spots had a bi-mail rate of 8.32. You can see the cold spots had a bi-mail rate of 12.47. What does N mean? Sample size. And so my sample size was 154 versus 163. This mu is the average, which is not going to, this average isn't going to count for this because we're looking at bi-mail rates. This is the average COVID rate here, of those hot spots and cold spots, which obviously are going to be different because one's in a hot spot, one's in a cold spot. But we can say, all right, 3 stars means that these are statistically different at p is less. So 99% confident, I can say that these are different. Now, why? I got no idea. Why are people in high COVID areas still showing up at the polls and not mailing things in? It might be just access to resources. I bet you, these are probably rural areas where people don't have the time, energy, or care to go avail the resources. So, all right, I guess I got to show up at the polling place. Who knows? This is the same thing with our food swamps. We've got food swamps here. We've got food access here. We can see the difference between these here. And anything with a little star means they're statistically different, where that average home value, 82 versus 93, is a difference of $11,000, but I threw it into the formula. It was not statistically different, so I can't say they're statistically different. But percentage of rentals, per capita income, percent minority. You can see percent minority, 18 points higher in rural food swamps than the best food access in rural area. Do you think that's a coincidence? No, it's not. Okay. Now, the other caveat that I have here before our break here, I'm almost done, is that I was talking about what we try to do is, well, if you disprove the null hypothesis, you're really not proving anything. You're just kind of proving that they're not statistically equal to each other, right? And so, so this kind of circuitous and convoluted, and this was part of the presentation that I gave last week, where that in the last 30 years, they've been looking at equivalence testing where I ran this through R. So there's something to do equivalence testing where where that instead of having null hypothesis, our null hypotheses are that these differences are less than zero. The null hypotheses are that they are not equivalent to each other. And then we kind of disprove the non-equivalence by saying they're equivalent. Yeah, I saw Daniel nod his head, so he gets it. Okay, all right. Wait, I think Dave kind of nodded his head a little bit. Okay. I'm not going to nod on anyone else. Okay. Okay. Well, this was part of our paper. This this is real kind of up and coming, new up and coming stuff here in the world of statistics. But it's called, these are called tests, two one-sided tests for equivalence, paired t-tests for equivalence. And so it looks for dissimilarity, and basically these are kind of my results. But if you need help with this, let me know because I can go revisit it. Be happy to go revisit it there. The only reason why I did that is because when I ran my original two-tailed t-test, there was only one thing that popped for me. And I'm like, well, it would really be a really bad paper if I said 9 out of the 10 methods worked. So 11, and 9 out of 10 methods didn't work. We just couldn't prove that they weren't equal to each other. That's it. I couldn't prove that. Last thing we have is ANOVA. Analysis of variance statistical method. Basically, it's a two-tailed t-test for more than two groups. And that's it. Is there a difference in high availability versus moderate availability versus low availability? And we've looked at these before. Paper that we did, I think we did it with, was that rural paper with Chima? Remember that rural paper we did, that ANOVAs?
Yes.
With Andy? Andy wasn't here yet. Tony? Samuel? And just you. Oh, whoa. Yeah, that was a good one. Oh, and the folks over at A&T. Okay, that one. So we did this where we said, let's look at the availability, and we can see that these are statistically different. When we get low p-values, they're statistically different. So let's look at the unavailable, good, bad, look at the counts. Let's find the sum of these. This might be, I don't even know what metrics we're looking at here. Might be COVID rates right here. I'm not sure. So if I see a 70, a 52, a 79, I know with a distribution of 63, now we're comparing 3 normal distribution curves against each other and make sure they line up with each other. And if I get something like this, I can say they don't line up with each other. I can't say the 52 is less than the other one. I can run my own independent two-tailed t-test against those. And I've seen those done before, but I typically don't run those. Okay, and you can. I think they're called paired two-tailed t-tests. I'm pretty sure paired two-tailed t-tests. And so we can look at things like, is there a difference in income between your unavailable, your good, and your bad? And I can see a p-value of 0.46, and we can say, no, there's no difference. People might sit here and argue, well, I got 51,000 versus a 47,000. But remember, it takes into account the mean, variance, sample size in that equation. So there's no differences in income. And so these are some of the things that we did where this is the paper, and some people liked my paper last week where we talked about what is rural. And I kind of get into these fundamental issues, and I like the quantification of the qualitative to the quantitative. Like I said, I don't like qualitative stuff because I want to just turn it into a number. And so when we say the word rural, we use the word, boonies, out in the middle of nowhere, all these other, sometimes pejoratives to describe it, but I want a number attached to it. And so there's like 9 different definitions of the word rural that has numbers attached to it, where this is from the census definition, which is based on population density. So these areas basically in white are classified as urban or non-rural. So these areas, according to the census, are rural. Here's another definition of rural based on the metropolitan statistical areas, MSAs, metropolitan. So this is rural in another definition. Here's another definition using something called the RUCAS, rural urban commuting areas. Right, Chima?
Yes.
Yeah. And this is USDA? Yeah, this is USDA. Now we can do some really precursory analysis by saying, just superimposing these and say, hey, the red areas have the most number of rurals, the green areas have the least number of rurals, the definitions. And so you can see this area in orange it's got 2 definitions of rural, but another definition, it doesn't satisfy the word rural at the zip code level. And because a lot of times I go to these conferences, and we kind of sit there and we're like, hey, in rural areas, it's this, and I'm the guy in the bag, like, what definition of rural did you use? Because there's lots of different definitions. Now, how do we know which one is different? How do we know who even cares, first of all? I saw Erica's raising her hand right there a little bit. Oh, you don't care. Okay. All right. Now, I care. Okay. The reason why I care. Okay. Now, when I run a test of 2 means for method 1, method 2, method 3, between rural and non-rural, you can see median household income is higher no matter what definition of rural or which definition of rural you use with rural versus non-rural. Why? Well, that makes sense. Rural incomes are always going to be higher. Now, in one method, it's 52,000 versus 43,000. Another, it's 50,000 versus 40. Another, it's 52. You know what I mean. But everyone's going to sit there and say, no, duh, of course, that makes sense. Yeah. So the one thing that I've done, and I'll kind of go back to it, is that now when I run a ANOVA for method 1, method 2, method 3, where it's 42,000 for one method, 40,000 for another method, 41,000 for another method, with this really robust sample sizes, we got 320, 191, 384. When I run the averages, my ANOVA tells me, hey, there's a 99% chance that when I take a random distribution of numbers with sample sizes 320, 191, and 384, you're not going to get numbers that different. That's why we use ANOVA. And so, like, if I'm doing income, I ask what definition of rural you're doing, because they're going to be statistically different no matter which one you use. And how dare you go and say the word rural without telling me in what context you use it? Now, okay, hey, what definition of rural are you using? And we did some other things with Jaccard indices to figure out method 3 was actually the quote unquote best definition of rural because it just compared with the others better. But when I ran it, the single factor ANOVA, you could see I ran ANOVAs for every single one of those. I extracted out method 1, method 2, method 3. It took me a little while. I ran little p-values and I put the little stars up there. This is what I got. This is the Y here. Where we have 2, 4, 8 here, 7, 8, 7. 1, 2, 3, 4. For a majority of the variables that we had for median household income, COVID rates, percent Democrat, distance to supermarkets. The numbers, the metrics were statistically different based on the definition you used. I think it's interesting. Okay, yeah. But that's why this is where ANOVAs can be applied. All right, so let's take 10 minutes here. We'll come back at 6:15. Let's get exercise number 7 opened up, because basically exercise number 7, you are going to write a short little thesis, prove it, disprove it. So we're going to get all those opened up, and we're really going to put on our GIS hats today and look at some really big, ugly data and maybe think about some ways to turn it into stuff that we can map. I get a little intense with my rural and ANOVA talk, so I need to settle down a little bit. I need to go get my Gatorade from my room and just. All right. Yeah, we're gonna fix that thing, and I got money in. Oh, yeah, I'm gonna try to cancel something.
Yeah, that's true, yeah. It's going there, because we want, I don't think it's pretty much all the sources work together. So I say, we're going to go to work, separate. I don't make my one.
Well, I was using playing here. Somebody didn't want that, so they did want that.
Yeah. So somebody fix that.
Oh, it's summertime. You don't need it.
I'm really just to look at
Yeah, get some. That's the game. Yeah, yeah.
So we're looking at it, like,
Yeah.
wasn't what presidents get this, but delicious stuff.
I have one.
It's put up on the table. It's like-
Yeah. Oh, that was my phone. Get my phone. With the box. Yeah. Later, nothing else.
This was.
Yes, we right. I have to. Those are healthy ones. Come on, then, continue in that lecture.
Be great, guys.
We was on the wall. We would be. What happened? Yeah. Right. I never say that. Again. There. That's why you're studying routed. He's shutting up. They are. Take it down. I swear. Yeah. I have a light in there down on the pictures. She don't have a national budget. They got the problems. Take me out of the, take me out of the, don't even be out of the long time. I don't, are you okay? Are you? Yes. Please, sorry. There we go. Team player. Teamwork. Yeah. But I'll. I'm with taking very much. Well, now tracks. Like, go home, go get I'll take out of the. Oh, you want me?
Okay.
People think about things like Appalachia.
Yeah,
Like that's cool, what, aside from the cities.
yep. And like using the MSA definition, Asheville is every county in Buncombe County would be rural, would be metropolitan, but it's not, so. All right, Andy, did you get a schedule for Wednesday? Yeah, we're going to Greenville. Okay. Yeah, I gotta figure out when I'm gonna pick you up, so. I don't wanna, but we have to, so. Want isn't really the operative word, but. Yeah, I'll figure out what time we need to be there, cause I kinda wanna leave a little early, like 3:30, 4 o'clock, cause I gotta be back in Greensboro. I wanna try to get back by 7. By 7 or something. I gotta been over here, so. Okay. You're the main, I'm just kind of the guy who pops in, says funny things and leaves and cuts checks, so. I'm pretty insignificant. All right, and while we're here, let's get this exercise 7 loaded up. Because the exercise 7 is, you're gonna have a lot of leeway with it. How many of them? Couple? That's fine. Those 2 exclamation points is not big. Yeah.
And just down at the bottom and some voters. That's what seems like that one.
That's okay, that's not bad. My main focus is on the dash 21 and the dash 22. Those 2. One up there. Yeah. Yeah, and while I'm here, I will. Yeah, we're gonna focus on this deaths 21, deaths 22, but I am gonna open up the. All right, yes, Journal of Rural Studies, David,
Oh, that's it down there.
that's
Okay.
this paper here. Look who we got. We got me and these folks, McGinn, and we got Chima up there. Yeah,
Like, my boss in the company.
yes. Yeah, it is a real life paper. Okay, all right. Yeah, I don't want to keep us, I want to knock this out here, so. Yeah,
Like we did during the.
what can they do? Yes. Yeah, I think a little more, I like that a little more for geostats because they do a position paper, but I forget what I did I don't know what I did this weekend, so. Yes. Oh, and this exercise? Yes. Oh, okay. Oh, I would like that, yeah. I would really like that. Okay, we're gonna start talking here. Now, a couple things we're gonna do here is we're gonna map and we're gonna make a hypothesis about gun deaths. You guys know Chantel in the PhD program? This was her idea for this class last year because no one else spoke up, so I was gonna regurgitate it again. But if you look over here on the left, you see a bunch of tables there. My tables might be different than your tables. Okay, they might be different because I didn't load this new project up there, which I thought I did. But my main thing I'm looking at is deaths 20, deaths 20 and deaths 21. Do you see in that standalone tables, do you see a deaths 20 and a deaths 21 in your ArcGIS Pro?
Yeah.
Yes, okay, that's all that counts. Now, a couple other things that we've got, and I'm gonna show you. I went and downloaded these from and I have a link to it, from the North Carolina Vital Statistics database. So we have deaths 2021. What do you think that's a table of? People died in 2021. And we're gonna open up, and I think we already know from Geostat what the different, there's probably about 50 or 60 different attributes. So when you die, they keep track of your age, race, what you died of, marital status, veteran status. And they've started adding new things lately, like they use tobacco, or is it a workplace injury, all these other things. So we can go and download these. So, that paper for the student who went and mapped all the African American female breast cancer deaths over the last 20 years, what do you think she spent a good time doing? Downloading these data and merging them all together. And we're going to merge just two tables together. Now, this project, what I've done in the standalone tables is that I've already downloaded deaths 21, deaths 2020, brought them into a GIS and exported them to the database so you don't have to work with CSV files. The CSV files get a little wonky here. They're like, hey, we're in the wrong location. You didn't bring the right folder in. So they get mad at us a lot. They get really mad at us. Now, the other thing I have too is North Carolina State Board of Elections data. Now, we have elections data for elections result, voter registration data. I can go and download every single voter in the entire state. We're looking at like 7 million records. I'm going to just show you a snapshot of these here in my ArcGIS Pro, and then we're going to get started. You can see here, I've got Durham voters, Alamance voters. I can right mouse click, and this is and I'm not sure if you all have this one here, but this is all 130,000 voters in Alamance County. Look how quickly it opened up in ArcGIS Pro. ArcGIS Pro can handle these robust. These are all the voters we have. So when I started doing my COVID stuff, where I looked at percent Democrat, percent Republican, percent Independent, I don't really know who voted for what. We don't know who voted for what, but we know what they're registered as. Right? We know what they're registered as. And so we can do things like, my parents live over, so we're going to out my parents and see what they really are here. But my parents live over in Alamance County, and I'm gonna type in the word Mulrooney and see if they're here. Oh, they're not. Oh, they need to be capitalized. There they are. And you see this big R, no, I'm just kidding, they are not here. So you can see my parents, and this is them from their voter registration database, where they live, zip code, confidential, they registered when they moved here, gender code, you can see their birth date, birth age, all that other stuff, voting precinct, but somewhere in here, they've got race, party affiliation. What do you think UNA means? Unaffiliated. And so typically, when we see Democrat, Republican, unaffiliated, they're typically about a third of each. You know, they're split equally. And basically, when you go and vote, or when these people run and vote and try to get your vote, they're just basically running for the, trying to figure out get the unaffiliated voters in states where people actually give a crap. That's basically what they're doing. You know, so this is what Dr. McGinn does for a living. You know, so he lives in this here. But it's got unattached. How can I, and just for the heck of it, how can I make this stuff GIS? How can I turn this tabular data into a GIS? What's some things I can do here?
Field that has XY values.
Join it to a field that has XY values. Couple things I could do. Well, I got their mailing address, so I can geocode. Oh, that'd be real hard. Okay, it'd take a long time and take a lot of credits, which is just Esri's code for money. And then, who remembers Samuel? Oh, you guys remember Samuel? Oh, well. He went and did a whole bunch of geocoding, and he didn't realize how much credits it used up, and used up all of our credits. And I tried to buy new credits at the end of the year, and it was like 100, you owe us $120,000. I'm like, we're gonna wait till the credits get reimbursed at the beginning of the year. So when we do geocoding, you do it for small areas. So I don't want to geocode 130,000 people, but like Daniel said, something that has XY values, telephone numbers, but over here somewhere we should have a zip code. The other thing we have is a precinct code, and there's typically GIS data layers out there of all the precincts. So you can look at all the precincts, but as part of their address, I'm just about positive in one of these here, they have a zip code, because typically these are your mailing lists. So your zip code right here, do you happen to see a GIS data laying around that has zip codes? Where is it? Right here.
Yeah.
Yes.
Yeah.
And so, like Daniel said, I can run a what? Summary. While I'm running the summary, I can add up all the R's. I can add up all the, or I can add up all the R's, add up all the D's, add up all the UNAs, add up all the L's, add up all the C's, or whatever the different parties are. So for each of these zip codes, I can get % Republican. Now, is it easy? It takes a little time. And now imagine not doing it for 100 counties, but bringing in the statewide database, because you're going to get some nulls right here, and you're going to get some garbage, and you're going to get some nulls for all these other things that you need to go through and clean up. And now, when I open up my zip codes, look what I have here. For every single zip code, I have COVID rates, but look what I have here. I really do have it here somewhere. I swear. There's something over here that has, okay, % unaffiliated, % Republican, % Democrat, number of registered voters. Here it is, yes. There we go. So in this zip code right here, it was 19% Democrat, 43% Republican, 35% unaffiliated, and then I ran a little algorithm to show which one was the majority. So it was majority of unaffiliated, Republican, Democrat. So I can just run a algorithm. I can run a little map that shows which one had the most from that original data we were looking at. Now, if you were to bring in if you were to bring in statewide voter registration, you're bringing in a big text file because these are originally text files, like 7 million records. And you'll group them by zip code. Because next week, what we're going to do is something called data cleaning. Like, hey, let's run a little Python, and wherever we see a null value, let's put in a Republican the first time. Let's put in a Democrat the second time, or maybe a random number generator that puts in something, a placeholder, because people might get a little weird, like, hey, there's 7.1 million registered voters, but there's only 6.8 numbers that add up to all the parties, and you're like, where are the other 300,000? Is this going to be another conspiracy like the 2020 election? It wasn't a conspiracy. No, I'm just kidding. It was not. It wasn't. So, but you can kind of clear, make yourself. These numbers can add up. So when I add up the Republicans, the Democrats, and there's other parties, probably 5 or 6 other parties that are listed there. Obviously Libertarian, there might even be a Green Party. There's a Green Party, maybe even a Communist Party. Who knows? That can be added up into those. So we can look at those as well. Okay, bring those in. Now, what we're going to do today is we're going to just go on Chantel's recommendation, and we are going to look at the 2021. 2020 data, and we are going to make a hypothesis that gun rates are higher in urban areas compared to rural areas. This gun homicides. Gun homicides are higher. Now, I've kind of taken out some of the stuff that you need to do for the sake of brevity, but when I right mouse click and open up deaths in 2020, deaths in 2021, we can look at all of these different codes here. And so I'm going to say gun deaths in 2020 and 2021, because we have 2020 and 2021 because it was the most recent years. We don't have the 2022, 2023, 2024 data sitting out there yet. So when I right mouse click and click on deaths 2021, this is a list of all 122,000 people who died in the state of North Carolina in 2021. It doesn't have their address. So I have something like BCNT. What do you think BCNT means? Birth country, birth state, DHT date, date of death, death month, death day, death year, sex, race. And if you remember from Geostats, we had these big DDRs, or what do they call DDFs, data dictionary files that tell you what a race of 2 means, what Hispanic means, what age of year. We have a 3-year-old who died here. The very top one. We can maybe go see what he died of. Seriously. Now, we don't know where he lived because all the way to the right, we have a zip code. And you can see here, we have a null zip code. But this poor kid died of W67. And I can just Google this real quick, or we have these open. You found yourself? Okay. Yep, you are. Now, this poor kid, 3-year-old, died of drowning. Drowning, and we can see the zip code, because I would venture to guess that we live in a world where all of these are spatially related. I bet you drownings are spatially related. Now, we might run into issues. How many drownings are there a year? There might be a couple. There's a lot. They might be spatially related. Maybe to age, maybe to race, maybe to other, like whatever. Okay. So this poor kid died of drowning in a secondary, which was T151. I'm not sure what that is. But remember, we can go through, to me, we could, Google these, but this poor kid. T15, foreign body and injury, poisoning. So this looks like some sort of injury or whatever. Now, ICD stands for International Classification of Disease. There's health geographers. I'm sure you're familiar with these. So I'm not, I assume these are for billing and stuff like that.
That's it.
For billing?
Yes, sir.
Yeah.
Yeah, billing, and they have nice, does, just info data from CPSC.
Oh, okay. Okay. All right, so we've got these 122,000 deaths. I want to combine these with the 2020. So I'm going to right mouse click, open data, and I can I only have 56,000 deaths in 2020. Why would there be so few deaths in 2020? Any idea?
It's at home, they're not doing something.
That's right. I would venture to guess.
Driving, they weren't.
Yes.
They jump in.
We're not going to look at this. Why is there no records here? Okay. We're just going to do 2021. Okay. Now, when we go to 2011, what do we see here? I have something called E-County, age months, age years. Do you notice the names of these attributes are slightly different? So in 2013, they made like a big change of the attributes. Ugh. That's not fun. No, it's not. Okay. So, but one of the things I can do here, and we're just going to work with 2021, but one of the things I can do is analysis, tools, and I can type in something called a merge. Does anyone remember that merge?
Yes.
So I can click on merge and I can say, hey, I want to merge my 2020. I want to merge my 2016. I want to merge my 2015 all together. Now, when I merge these, I can merge all these tables together so I can get multiple years of stuff. We're not going to merge it. We're just going to work with 2021 and look at gun homicides. That's all we're going to do. Now, over here, if you got different field names, it's going to get really wacky really quickly. But you notice all the field names like, hey, I have something called B_CNT. That's birth county. I have 3 different birth counties. Do you just want those birth counties to line up with each other? And we're like, yeah, of course, that'd be great. But when we start looking at some of the early stuff from 2011, now watch this. If I add in like 2011, it starts getting wonky because now I've got something here with 4 of them like code 1, and then I have something that's like B date, D month instead of DHT date. And so now what you have to do is something called attribute field mapping to say, hey, this injury goes up here, and I can kind of drag these in different places, but I can click on my little field map and figure out where this one goes. Like, hey, wherever I see a B state, I'm going to drag it up to B_ST. Okay. Now, typically what people have done in the past, and what my student, her name's Alana, or was Alana, was that she went and got the old stuff from 2000 to 2013, made it one file. She got the stuff from 2014 to 2020, made it one file, and then just combined the 2 files together to 2 really big files that had a couple million records each, but combined them together. And it was really able to be done pretty well in ArcGIS Pro, where that's something like Excel would just quit on you. You know, especially, you know, cutting and pasting and importing. That's where I kind of get a little lost with Excel. Okay. So we have the idea of merge. So if you're going to do death data, I'm looking at you all here too. If you're going to do death data, you just run a nice little tabular merge. Now you're going to have to do some stuff. Go back to week 1 from Geostats and look at the DDF files because it says, hey, for 2013 before, it's got this stuff. For 2014 after, it's got these. And this is where you make your big bucks as a GIS tech, as a GIS analyst. Where like someone says, hey, I want to map all the deaths in North Carolina since 1990. You've got yourself about 3 or 4 days of work where you're just downloading all the things, making sure they're lining up. Because when your boss says, like, why do we have 2 separate counties here? and one says Berth County, one says B County, and you didn't match them together, your boss isn't going to want to say, just let me do it myself. Because guess what you'll be doing if they're doing it themselves? You should be looking for a new job. Yes. Okay, and then this is where you make your big bucks, you know, a lot of this, you know, death data and all these, you know, even the zip code data with the percent Democrat, percent Republican, they didn't just magically appear. No, Ernie made them appear. You know, I put all those in there using some of the techniques, the summarizes. Okay, hey, while we're here, let's count up the Republican, let's count up the Democrat. Okay, hey, let's run a summary while we're counting, you know, it's tricky, it takes a little time, but once you get something that says zip code, number of Republicans, number of Democrats, number of unaffiliated, we could join it right to that zip code, and we've got GIS data ready to go. That's the only difference between this class and other classes in data science where that we're just expressing these and figuring out how to put these onto a map. All right, so let's go back to what Chantel wanted to do. And so for 2021, our assumption, what we're going to do is I want to extract out the gun deaths. I provided a couple of links here on ICD codes, but one was from the Massachusetts Department, Massachusetts government, and these are ICD codes for their Population Health Information Tool. Population Health Information Tool. And so these are the different ICD codes. Typically, anything that starts with the letter C is cancer. So what you died of. So we saw that poor 3-year-old or all the way up the top died of a drowning. T67. So these are the general categories. To me, I can Google these. There's typically ICD codes because they use these across a lot of things, across health, across medical billing, everything. So these are used across a lot of different fields. So what we're going to look at is firearms. Homicide firearms in 2021, and they're going to be code X93 to X95. How many do you think there were in North Carolina? Gun deaths, a lot? How much is a lot? Okay. All right. How do we query out X93? And we're just looking at code 1 because a lot of times we're looking at this code 1, which is the primary code. Primary code right here. So you can see the people with the C's or the cancer and other things. I want to just look for, of these 122,066, how many of them were X93, X94, or X95? How do we do that? I'm looking at David, who took GIS recently.
We filter.
Filter, what's another word for filter in GIS? Starts with a Q. Query. We could sort them, but that did take a little more time. Yeah, query. Okay, so remember, we're going to go to map, select by attributes. Okay, select by attributes. And just for the heck of it, you know what I see? I don't see, and let me just see, X9. Okay, so I want to look for X90 because I was going to just look for anything that was X9, but I see cutting or piercing, which I assume is stabbing. So I don't want to say we don't want them, but we're just looking for firearms, you know. So what am I going to look for under the input rows? I'm going to look for deaths 2021, where what? Code 1 is equal to what? Yeah. Let me look for X. Swear I'm doing it right here. X. I don't think you can try it. Yeah. I'm just going to run this here where it's equal to this. Yeah, add the clause, code 1, but Daniel's probably onto something, but I just want to make sure I show everyone where it is. And then code 1 is equal to, now is this, so the code 1, basically that's the primary code. Because a lot of times if you're older, you die of a lot of things, right? You know, and they put a primary code, you know, dementia or whatever, you know, whatever. My grandmother's on here and I had a whole bunch of things because she was in her 90s. Now, I have the word and here. What's the word and mean?
And means it has to satisfy all three of those.
Yes, do I want and or do we want or? We want or, exactly. Because remember, that's going to be a logical error. It can only be one of these. So I want 91 or 92 or 93 or 93, 94 or 95, even though we're looking for codes 93, 94, 95. This is how we use it colloquially, like in our everyday language, but really semantically, we want to use the or. It can only be one of them. It can't be both at the same time. Okay. And so remember, we're moving from the qualitative to the quantitative where really it's right or wrong. And when we run the ands, it's just going to say 0, and there are going to be people, not in this class, people will say, oh, I guess no one died of a firearm in 2021, and okay, that's the answer. Okay. All right, and I'm going to click apply. 887. But 887 people died of firearms. And I'm recording this so people can see it and we can go back and revisit it because now we can do our geostat stuff. What do you think, just for the heck of it, what do you think the average age was of those people who died of firearms? Huh? Look, just look at here. I see 18, 18, 21, 23, 19, 23, 54. Who's the oldest person who died of a firearm of these? We got a 97-year-old who died of a firearm. What do you think the youngest is? 2. But I can right mouse click and I can do, I swear, there's statistics, right? Explore statistics, visualize. Yeah, we want, there we go. So here's a normal distribution. Remember, I keep harping on this normal distribution curve, but look what we have here. The average age at which people die of a firearm in North Carolina displays a what? Normal distribution. It does. Now, the average age of all people are going to be what? They're probably going to go up here, high here, and then trail here, because you're not going to have the same number on one side of the average age, which is 70-something, as opposed to the other side. What do we have here? And now remember, we can right mouse click, we can look at our mean, median, standard deviations, and what is our mean age? We're 32 years old is the average age of the victim. And then we can run a summarize on what? We can right mouse click on sex. We can right mouse, and if we wanted to, we can, I swear, we can, ArcGIS, this ArcGIS Pro looks just a little different here. But just for the heck of it, I ran a summarize, and what do we have? 731 males, 156 women. Males are much younger than the women. What might that tell you? What might that tell you if the males are so much younger than the women? I have some ideas. Gang violence versus women, where are they? Maybe dying of homicides. Domestic violence situations, maybe? No. Now, we're not in the Y business, but these are nice little statistics that we can pop up here from this data set that we had just downloaded off some website a while ago. And now we're getting really specific, asking for really direct and intentional questions that have implication with public health and everything else. So which I think is kind of interesting. Okay, next thing, what do we want to do here? Okay, so we got all these deaths. Okay. So we want to map these by zip code, right? Remember what we do? Right mouse click, summarize. I'm going to right mouse click and summarize. What does this map tell me? What does this tell me? I've got a zip code. and a frequency. Look at, there's a zip code 27105, 27406 with 13. I think 27406 is over near me. 27105 had 13 people die. That's Greensboro, that's me. Yeah, that's in Guilford County, yeah, that's, my wife calls this area south of 40, we don't wanna go south of 40. Yeah. So we can see this here. Now, we wanna figure out, hey, let's make a map of this stuff, calculate a couple rates and go from here. What's the one problem that we have with running a join? What's the first problem we have? So now, let's get rid of the deaths. Okay, because in this table in the bottom, what we want to do is, hey, let's just keep the stuff we want to keep. So now I've got a summary table of the 353 zip codes. So about a little less than half of all zip codes in North Carolina have had a gun death in 2021. Think about that. That's a lot. Right? That's a lot. Now, I'm kind of interested to see if my zip code has had, how safe is it? Let's see, where am I? 2735, we had one. Okay, all right, but what we're gonna do now is we're gonna go and map all these. So, all right, so now we got our zip codes, right mouse click, open, because what we're gonna do here, we're just gonna add a brand new column to what? Percent Democrat, percent Republican. What are we gonna add it to? This is age grade. We're doing some raw age grades, all these other things here. Pop. We're just gonna add a new column that has what? Total number of deaths. What's the one problem we see here? We have a zip code here. We've got a zip code here. Now, some of you notice that this is left justified. This is right justified. What does the right justification mean? It wants it to read as it's a number. We need to do something called typecasting. Now, my buddy at NC State, he showed me this little trick that we can typecast while we're doing the summarize, but I forgot it until now, so I'm going to just show us how to do it. It's pretty straightforward, right? We do a field view. What are we going to do? We're going to have something called a zip code as a text. We're going to make it a what? Text. And we're going to give it a length of 10. Why? Because zip codes are only 555. And we're going to click save. We're going to go back to my death statistics and we're just going to calculate the brand new field. Hey, and this is called typecasting, where I'm going to just say zip code. Bippity boppity boo. Now it's left justified versus right justified. So now I can run a tabular join. Basically, wherever it sees a 27024, it's going to add a brand new, it's going to add this table to the end of my zip code table, which is already attached to points, lines, and polygons. Just for the heck of it, you know what I'm going to do? I'm going to do a field view, and I'm just going to type in the word gun rate, because aren't we going to want to compute the gun rate at some point in time? There we go. Just for later, we got gun rate. So I got my zip text, my gun rate. What does the word frequency mean? Amount of time, the frequency, the number of times a zip code appeared for a homicide for Z93, 94, 95. This is specific. Like we're just downloading stuff, and now we're like looking at, hey, my zip code had 1 or whatever. And we can get specific about ages. Obviously we got ages, but race and race, age. I don't think there's anything in there about socioeconomic status. So now I got my zip codes. I'm going to right mouse click. I'm going to do join. I'm going to do add a join. So all I'm doing, this is called the tabular join. So my input field is going to be my ID with my death 21 statistics with my little zip text, right? I want to validate my join just for the heck of it. What? Uh-oh, join had no matches. Why? Because I got to clear that. Now I'm going to validate my join. Now it says one-to-one join is matched for 311 records with 353, one-to-one for 311. Why is there a difference between 353 and 311? There's some zip codes that appear out of the state, it looks like, right? So I don't know how those deaths are cataloged or whatever. So maybe someone lived out of state, was shot in state, and so that quote unquote counts or whatever. All right, so close. So now I got a brand new column that I can go and map sitting here of frequency. Who wants to map this? I definitely do. So I can right mouse click, go to my symbology. I'm kind of fumbling around a little bit here because I installed the new ArcGIS Pro, so everything's not in the right place, or not in the right. So this is like total population. This is median household income, right? I like mapping everything using quantiles, right? So we can see where income is higher. We can see where, hey, poverty rate's higher. You know, lots of these things right here. We're going to go all the way to the bottom and we're going to look at frequency. What we have, what just anecdotally, can we start to prove or disprove Chantel's hypothesis? Just anecdotally. What's anecdotally mean? Just mean story, story. Like I know someone who or whatever. Anecdotally, just looking at the map, hey, rural, dark, rural, dark, rural, dark, rural, dark. Okay? Durham area is dark, but what is that word? Sanford? Right there? That's kind of rural, dark. This whole stretch here is rural, but it's dark. So just anecdotally, we can say, hey, look, these are pretty. What's that? Yeah. So just a map here, we can say that. Now, the other thing we want to do is we want to map the gun rate, right? There might be a lot of people who happen to live in the zip code. Now, the thing about zip codes, and especially census tracts and block groups, is that they try to make the census tracts and block groups about the same population, even though we know they grow and then after 10 years they split them up. But so that's why I have this gun rate here. So just for the heck of it, now we're gonna deal with small number problems because we have granular numbers like 1, 2, 3, 4, 5, 6. So that's why I kind of wanted to get 2020, 2021, because we get more and we might even get more zip codes. And you get it for 20 years. Hey, we can do gun rates. We've got 117, 23, 87. So we can get some real granular rates here. And so I can calculate the gun rate where I calculate the field, which is just going to be, we're going to do 10,000 times what? The frequency divided by the population, total population. So this is the number of people joint field statistics generator is not allowed. Why doesn't it like, I know why. Just for the heck of it, I should probably just export this table. Is that a good idea, Chima?
So,
Well, for now, I just want to calculate the gun rate. Basically, it was giving me that problem because,
export, so you can save to the
yeah, it didn't like this gun rate because it's saying, hey, you have a join, it's connected to something else, but you're kind of calculate the connected table within it. So now what do we have here? We've got a frequency, we've got a, we know what we have here. And then I'm just going to do a fields view. I'm going to go to the bottom and add another gun rate here. Save. So it didn't like me working off that individual table within the confines of a join relationship. Does that sound smart? Okay, good. That's all I wanted to do. All right, so I got the rate. So I'm going to just right mouse click again, calculate field. And that's the thing about GIS. Like I didn't know that. I just figured it out. I read the directions. I ran it twice. I have red stuff popping up. All right, go do something different till it works. And that's kind of part of problem solving. And so once again, we've got 10,000. Why do I use the 10,000 here? It's the size of a zip code, and also I could do per capita, but what is my per capita value going to be? 0.000232. What does 0.00023 deaths look like? I know what 2.3 deaths for every 10,000 people looks like. I know what 10,000 people looks like. It looks like all students, faculty, and staff on this campus. So every group of people of this size, 2.3 people a year die of gun deaths. I get a lot of nulls here, so it's going to calculate these as zeros. So I get a lot of nulls. I get some zeros here. So now I can right mouse click, symbology. I'm going to go to graduated colors, and I'm just going to go down to my little rates here. We're going to get a lot of null values. What's this word null mean again? No value, not zero, nothing. Good. Now look at these rates. All right, so now this one right here, this zip code right down here, 11.3 people for every 10,000 people. Now there's only 3 of them. And so what are some caveats that you have here? This might have been a murder-suicide in a house, killed 3 people, that probably wouldn't happen again, but it counts as the highest because, so that's why we want longitudinal data. Has anyone heard that term, longitudinal data? Something Chima works with where, hey, I want to work with data over a long period of time. That's what I want, long period of time. Let me get some longitudinal data so I can, so now that 3 in 10 years, that might only go up to 4 because of that isolated incident. Now, the last thing we're going to do is, let's prove or disprove what Chantel said. Now, just for the heck of it, so what are things here that can tell me if something's urban or rural? Oh, look at urban rural RUCAs. I classified these already. I think maybe my urban rural paper, I did this. So now what do we have here? We got definitions so that I can just pop right into Excel to prove or disprove what we have here. So I guess this is an old paper that this is maybe the stuff we did on our paper. So I went and did our RUCAs, rural urban commuting patterns. All those do is just, there's other definitions of rural, here's another rural. This is rural using population densities used by the Census Bureau versus MSAs used by OMB, Office of Management and Budget in the United States. So now what do I do here? We're in home stretch. Home stretch. So now I can select by attributes. My zip code's final. What do I want to find? I want to just find where frequency is not null because I don't want to pick out the null values. And what's that thing here? Some RUCA thing. Where's the RUCA thing I'm looking at? RUCA is equal to rural. So I got 99 of these here. just for the heck of it, let's see what the rate is. Right mouse click. Oh, I don't want to do explore statistics. What do I do? Visualize statistics? This is a whole new thing that I got to teach in geostats. Okay. Visualize statistics. What do we have here? My data set is 1.7. What is my selection? 2.59. What do you think that's telling you? The entire selection, because this entire selection, look, it's not counting the nulls. It's only counting the 311. What's that tell you? Where's it being skewed? Let's run this again. Watch this. Okay, remember these numbers here. Now I'm going to click urban, click apply. What did we just do to our selection? Went from 2.59 for rural down to 1.39 for urban. Yeah.
That's what I said earlier.
But at almost twice the rate. We have gun homicides. And these are homicides, so these aren't even accidental deaths, because I would imagine there's an ICD code for accidental deaths, suicides, all those other things. And so we can look, and there are people who make livings out of these. These are homicides, like homicide, person killing someone else, person killing someone else. I don't know about this stuff here, so I'm just gonna, we're going to go in like that, yes.
It makes sense. I was thinking, because the code for homicide was X.
Yes.
But it's homicide by firearm or homicide by third person.
Yes, and it's got this X87.1, this is Y09, because it looks like these are just select ICD codes. And so I thought these were pretty good. I thought this webpage was pretty good about specifying which was which here. Because you can go to like ICD-10.org and they get really, they get convoluted, they get specific here. Because there's a lot, you could get, hit over the head with, I'm sure there's lots of ways to kill someone. And so we can look at all these causes of homicide. We can query all of those that we can do. But we're just looking specifically at, guns. Now, even though the urban is half the rural rates, well, there's some caveats like, hey, maybe this was just a bad year in rural. So if you were going to do a master's thesis or a PhD dissertation, how many people would be interested in this for a dissertation or something? No one's, everyone's looking away. Knocking out a paper on something like this, especially with something like public safety or whatever, because I already have a template for it. We already wrote a paper on female African-American cancer deaths. Now we're just looking at homicides, and which are both, all of these are public health crises, public health crises. Now, even though one's twice as much as the other, let's just go and pop this into Excel. Just for the heck of it. So now what do we have here? All right, remember we did this. Oh, okay. Copy highlighted. Why doesn't it let me copy highlighted? I'm looking at Andy. Why doesn't it let me copy highlighted in? I'm just. I want to put these in Excel. I don't want to export. That takes too much time. Right? Copy highlighted.
Is it just because you have that window open up there, the chart properties window?
Oh, well, yeah. Well, maybe we'll change something. Let's change another thing. Let's keep. All right, good. 212. Okay. I'm gonna cut. Yeah, that's a weird switch right there. All right. So what are these? that we're looking at. These are urbans, okay. So we're gonna we're gonna open up our Excel. We did this last semester, remember? I swear I'm opening up Excel, okay. So, boom. Then we're gonna right mouse click, we're gonna call this urban. And then we're gonna do select by attributes. We're gonna click rural, we're gonna click apply. I guess I'm gonna do this switch again. That's kind of weird running that switch, but it activates these. Now these are rurals. You see that Sanford one right there. We see some Havelock. We see these out here. And so you always gotta kind of cover your rear end, like, hey, make sure these yellows and these highlighted are really in quote unquote rural areas. And then you see this strip all the way across here. That's problematic. Just to be cute, or oops, hold on, we're gonna rename it rural, so when you come back and watch this later. Now, what are we gonna do? We're just gonna compare this distribution of rates to this distribution of rates. All we're gonna look at is the bell curve for that last column versus the other column. They have a different sample size, right? Because how do you expect there to be the exact same number of rurals and urbans that happen to have a homicide in those for a year? Because I think one was like 99, the other was 212. And so there were 111 zip codes that had a homicide. And we're almost done here. And so what do we do here? We go to data. Get you out of the way. Uh-oh. Oh, I installed new, always forget to do this. Okay, options. Add-ins. I gotta perform here. This is scary. I'm getting scared, Andy. Oh, there we go. My analysis tool pack and my Euro convert. So now I go to data. I got my data analysis here. Now we can run two-tailed t-test, test of two means, all these other things in R, SPSS if you've heard of that, SAS if you've heard of that. We're just doing two really simple comparisons. So my go-to here is, Excel. And this is kind of the extent of it, but we could have done this. We could have write a nice little R program to do this in R and never have to worry about this again. So we are going to do a two-tailed t-test assuming equal variances. What's going to be the first one? This column right here. Why aren't I picking up frequency? Or why aren't I using frequency? What's that? P equals 5.7 E negative 10. What's that mean? It's really, really, really small. It's 0.00000000001 or whatever those numbers are. Okay, small. Okay, it's really small. Now, some things that we probably needed to do was all those nulls, I probably should have converted those to zeros. Should have converted those to zeros. Yeah. Because there might be more in the rural as opposed to the urban to kind of even those things out. But when we look at just those that happen to have homicides in those, they're statistically different. So I probably should have done all 750, but I didn't want to go back and recalculate all that other stuff. So now for homework, we've got these sitting here. For homework, there's really, I don't want to say no homework, but homework is going to be up to you. Kind of what Chima was alluding to is that we're going to look at we tried to look at gun deaths for 2020 and 2021. I'm not sure why that 2020 stuff didn't go through. Might have been part of my upload or something like that where things didn't bring in. But what we want to do is include data from some big data source that we're going to derive it from. And so what you're going to do is you're going to create a short research problem and create a hypothesis. Research hypothesis. We might just say gun death, violence deaths occur more in urban areas compared to rural areas. We've actually proved the opposite. Now, what I would expect was, hey, let's go back and do all the zero values and bring those in. And all you need to do is you don't even need, you can bring those nulls into Excel and just drag a zero. So you don't have to recalculate those in ArcGIS Pro. Hey, let me just copy anything that's rural, put it in there, do a find and replace with the null with a zero, and I've got my values and I got a bunch of nulls. I don't know how many bunches of nulls there are. So another one we could do, exploration of sociodemographics of suicide deaths in 2021. Use that table and say, hey, let's look at suicide deaths. What was the average age? What was the average age? Breakdown of the ages, breakdown of the races. Let's look at the zip codes where they were. Is there some association with socioeconomics? Is it a rich problem? Is it a middle class problem? Is it a poor problem? I have some ideas. To me, I probably think it's across the board, right? That might be interesting. Right. So you're going to create a research hypothesis. You're going to write a just short 1 to 1.5 page kind of position paper that proves or disproves this hypothesis. And that's my big concern. A lot of times when people do theses and projects, I want to do this. What are you trying to prove? Even my own PhD dissertation was, I want to write a open source application. That's cool. What are you going to do to test it? Okay, I want to see how well this open source application works compared to non-open source, or it compares to just pointing and clicking, you know? And so the open source application is great, but a way to test and evaluate it where I convert. I liked it to a 3 and I run my testing on it. So you're going to write a short 1 to 1.5 page paper. Where'd you get the data from? What can you conclude from it? Did you prove or disprove your hypothesis? We just saw something now where just using our limited data and our limited functionality, we found the opposite. Hey, rural gun death rates were actually higher in zip codes where there were gun deaths compared to urban areas. We expected kind of the opposite. Okay, now, last year I had a whole bunch of people who said, I don't know what I want to do, and like shrugged their shoulders. So if you don't know what to do, due to the presence of noxious elements around cities, lung cancer deaths are higher in urban areas compared to rural areas for the years 2020 and 2021. So that's what you will be doing if you need to ask daddy. If daddy has to figure something out, you don't want that. You two figure it out. You three figure it out. What's that? Yes, so I will figure it out if you can't. So, okay. So a couple things you need to do. One thing that you need to do, if you want to get the 2020, the 2021 and the 2020, you might need to go re-download it, the 2020, because it looked kind of, it was incomplete. There was a lot of missing data. Just to make sure, just download it. What does that TAB mean? Tabular data table. Basically, it's tab limited. So when you bring it into Excel, wherever it sees a tab, it's going to put it in its own cell. So all of these things are importable into Excel, definitely importable into ArcGIS Pro, and then we can go to there. So, you know, there's my tab limited. Sure, accept. Of course, I accept it all. I would. And so to me, the only limitation on these is your motivation, but your creativity. You know, what is something that's really important to you? What is something that's impacted you? You know, is suicide impacting, gun death, motor vehicle crashes. We had a student named Cameron who motor vehicle crashes in North. So he went and did a few years of motor vehicle crashes and saw they were really high, where there were actually lots of gun deaths in southeastern North Carolina. Child deaths, drownings, all these other things. Are there differences between drownings across ages and races, and where are they highest? But when I download these, you know, these tabular data, you know, this is what it looks like in Excel. You can see little tabs here, but I bring the 2020 deaths in. Here. It's going to look really slick, really quickly. It's gonna look really slick. I swear it's gonna look really slick. Remember, for some of these tabulated, you gotta go to all files. There we go. And now here's the 2020 data sitting here. Boom. Yep, we got 112,000 records for 2020. So that garbage that I had in 2020, this probably includes COVID stuff. And I bet you there's probably new ICD codes for COVID or whatever. 112,000. So that 2020 data is probably, I probably zipped it up before it got imported or something. I'll find someone else to blame. So I can't blame myself, but someone else will be blamed for it. But if you want to get the real file, it does have it. It does have it there. Okay. Any questions for me? I like this exercise because it's not a have to, and you give me code on things that you don't want to do. It's something that you really like, you know, how many fire related deaths are there? Accidental deaths are there? Needless deaths are there? You know, are they split between males and females? Are there certain, deaths out there or certain types of deaths where there are more females than males? Because you can imagine with homicides and accidents and probably drownings, there's more males than females. And so any type of explorations just at the 2021 deaths, or maybe work on some of your merge capabilities, because you're going to have to combine data sets if you want to do anything of substance or thesis or project or anything like that, for this or for GERS, we can do this. All right, that's enough for me today, right? All right, somebody, yes, definitely. I get into this stuff. I get really excited about this stuff. So this is one of my favorite exercises for a reason. So I get pretty passionate about it. So utilize the skills, two-tailed t-tests, ANOVAs. We're bringing in some of the GISE stuff with the spatial statistics and the clustering, which we kind of glossed over today, because my assumption is you'll take it next semester or you've already taken it, and then just the need for normalized data and consistency and all that other good stuff, which we try to do by calculating the rates, even though we should have brought in some of these zero values as well. All right, we'll see you all later, and have a good week. Be on the lookout for an announcement tomorrow, and be on the lookout for a place to put your GERS stuff so I can kind of give you your grades for the final, and then we'll post a schedule for the final exam in 4 weeks. Yeah. Final exams in 4 weeks. We only got 3 more of these classes, I think. Yep. 3 more of these classes.